answer session.
Yes, sir.
Thank you. The floor is yours.
Sir, is my screen is visible?
Yeah, it is visible.
Thank you, sir. Assalamu alaikum, everyone. I am Ashik Iqbal from IWF and BUET. The title of my presentation is Flood Propagation Process in the Jamuna River Floodplain in Sirajganj. The work is funded by the Core Bangladesh Research Project of IWF and BUET. Here is the background of the study. Bangladesh is a land of river. About 80% land of Bangladesh is a floodplain, and about 20% to 30% land face riverine flooding every year by overtopping of the river. Sirajganj is located beside the Jamuna River and have many low-lying unprotected floodplain that is frequently flooded. Due to climate change, riverbed siltation, and crossment of river, the flood events are becoming more severe. Flood Forecasting and Warning Center of Bangladesh Water Development Board collect and forecast flood data at river. But there is no monitoring in the floodplain. Along with FFWC, a lot of modeling approach has been taken, focusing the channel mainly. Here is the objective of my study. The main objective of this study is to explore the flood process in the floodplain in Ranigram area of Sirajganj. The specific objectives are to find out the flood process in a floodplain of Jamuna River through a statistical relation with the river stage. And the second objective is to develop a two-dimensional hydrodynamic model in HECRAS with a high resolution UAV generated DEM and validate with field data at local level. Here is the methodological framework of my work. At first, 3 water level gauges were installed at the strategically selected locations of the Ranigram, and then regular flood depth at the gauges and flood photos and other information from the study area was collected during flood. FFWC measure daily water level at Jamuna. So daily water level at Sirajganj point was collected for the same time period. And then a statistical relation of the flood water level at Ranigram with the water level at Jamuna at Sirajganj is developed. Then a two-dimensional hydrodynamic model was developed with HECRAS, where stage hydrograph and normal depth was used as boundary condition. The water level data used for boundary condition is the water level data at Ranigram at Union Porishad that was generated from the statistical relation using the water level data of Jamuna at Sirajganj. Then the model result was calibrated and validated. Then this model was run with different types of dams. High resolution UAV dam was generated with UAV and other satellite-based dams were collected. Finally, flood maps were compared with flood photos at the exact locations. Here's the statistical. Here's the study area. Ranigram is in Sirajganj Chador, located just beside the Jamuna River and beside the Sirajganj SW49 station of Bangladesh Water Development Board. And then how the flood propagates in the Ranigram area. At first, the water from Jamuna comes to the eastern area of the village by overtopping, and from the Chor area. There is a bridge beside the Union Porishad that is shown in the picture. At first, the water enters through the bridge and it propagates in the northern part of the village from the Union Porishad and comes to the southern part of the village through the culvert point. And the location of the 3 water level gauge install is pointed here. Then statistical relation of floodplain water level at Ranigram and Jamuna water level is developed. The contribution of Jamuna water level in Ranigram is far dominant over the contribution of rainfall. So that's why the mainly Jamuna water level is considered for the study. Here, the daily water level at Jamuna River and water level at the flood gauges at Ranigram for monsoon 2018 is shown in the graph. from the table, we can see that the water level at gauges have some correlation with the previous day's water level of Jamuna. And here the correlation R square mean absolute error, root mean square error, and Nash Sutcliffe efficiency for simple regression is calculated later. The table 3 shows the R square value, mean absolute error, root mean square error, and Nash Sutcliffe efficiency. Also, the figure below, it shows the residual from the simple regression. Overall, the linear model performed good for the Ranigram area, but the residual is higher for the days when there was a sudden rise or fall in the Jamuna River, and at the beginning and at the end of the flood. Here, the statistical relation that was developed from 2018 data were used to generate water level data for exact location in the village using the water level of Jamuna River for 2020, and then compared with the measured water level data in the village area. And here also the R square value, NSE value shows good relation, and mean absolute error and root mean square error shows that the model is very good. Then HECRAS two-dimensional hydrodynamic model with a high resolution EF generated demo was uh, performed. The high resolution demo was generated using UAV with drone, and having the ground control point with measured bathymetry data. The UAV-based DEM was used as a terrain for the 2D flow area, and two external boundary condition was used where at the breaching point of Union Purishod, the stress hydrograph was used, and the normal depth was used at the down. And here shows that from the model was calibrated with 2018 data. Here it shows that from the simulation, the water level data at the cell locations of water level gauge were taken and compared with the measured water level for 2018 at culvert and pilot site, which shows good result. And then the model was validated with 2020 data. Here also the water level at Union Purishod point was developed using the statistical relation with Jamuna River of at Sirajganj point, and then the model was run with this boundary condition data. And the result from HICRAS at a culvert and pilot point were taken and compared, and it also shows a good result. Then some photos from the field during flood was collected, and flood maps for these exact dates were exported, and at the location of the photos the flood scenario was compared with the flood maps. The flood maps from the model shows similar type of scenario to the flood photos, and from here you can see that the model with UAV DEM can represent somehow accurate flood scenario at the locality. Then the model was run with different types of DEM. One UAV based DEM that was generated, and other wall DEM from Airbus and Allospulsar, and SRTM 30-meter DEM was used for the modeling. Here, the wall dam shows a similar extent of result in the lower elevated agricultural area, but in the tree canopy area, there is no flooding when the wall dam was used. And for SRTM and Pulsar dam, the result shows very much different from the real flood scenario, which can be because of the low resolution of the satellite-based dam. After that, the maps for arrival time, duration, and maximum depth were generated. Then flood maps for of Ranigram for different return period water level was generated using
Ashi,
the
try to come back
UAV.
in the next 2 minutes.
Yeah, yes, sir. the flood maps for 1 year, 2 year, 10 year, 20 year, 50 year, and 100 year return period is shown here. We can see that the lower agricultural lands gets inundated every year, and even for 2 year return period flood, the whole area is flooded, and for 50 and 100 year return period flood, even the housing lands gets flooded about 1.5 meter depth. And here is the conclusion of my study. The statistical relation of flood water level in the riverside area is linear and have good relation with the water level of Jamuna River at Sirajganj point. A two-dimensional hydrodynamic model with high resolution UAV based dam can represent more accurate flood scenario at the local level in the floodplain. We can see that the more field data frequency can contribute to the accuracy of the model, and the floodwater depth at a certain location of the floodplain can be obtained from this model, and this information can be useful in flood risk and damage assessment, and also forecasting flood in the floodplain areas. Thank you, sir. If any question.
Thank you, Mr. Ashik Iqbal.
Okay, then. So we will move to the next presenter, Ashik Iqbal. The way I can see that we have questions, two questions. I understand the relationship of the stages, but flood process is more than just the stage. I do not understand the process part here. Can you elaborate a bit more in this regard by the co-chair?
Yes, sir. At the beginning, mainly the relationship stages I have shown, but with the HECRAS model, from there we can have flood maps, velocity, discharge, etc. So from this HECRAS model, we can have the flood processes.
Professor, are you satisfied with the answer?
We can. I don't know. Probably I missed out on the slide. Did you really shown in the HECRAS model output?
Sir, I have shown the arrival time map, the duration map, and maximum flood map, maximum flood
So
depth map.
the time lapse is very important. Particularly when you're preparing for certain a flood wave at Kajipur, and then how this particular wave would basically arrive at your particular location, right?
Yes, sir.
And I have another question regarding you use drones for collecting data. So it's a good thing that you have very high resolution data, but the area is very small, isn't it?
Yes,
compared to the can you
2.4
basically
kilometers.
suggest whether it would be really suitable to get this high resolution data, or the comparison between using this high resolution data and relatively poor resolution data, freely available data? How far improvement does it make into? Because it's very expensive, if like for BWDB or any other agency to take on your methodology, which is fine, but is it really affordable in the short term for us? Maybe the question is a bit hard, but try to.
Yes, sir, I got it. My area is only 2.4 kilometers square, so that was a little bit easy for me. But if we consider more area, one thing we have some measured bathymetry in a few areas by our some government organizations. So we can use them for as ground control points, and have the drone cost of drone is not that much. Maybe we can have people can have buy a drone with 2 or 3 lakhs, and if people can learn the technique, they can make this from their own self.
Excuse me, I would like to add to Abid sir query a bit. If I am Jamal,
yes, please.
Sir, there is actually something very interesting that has been developing right now in CNES, in French Space Agency, basically. So what they use is a method called tristereoscopy. So in this method, one place, just like the drone, one place is mapped, kind of taken a photo from 3, 4, or even more angles. And then using these images, very nearby images, they can produce very high resolution DEM from space for a very large area with quite high accuracy. The resolution can go around 20 to 50 centimeter, in fact.
Very high.
And those can be those kind of method could be kind of incorporated in this large picture. And there is the upcoming project in 2023 that they're supposed to make those kind of images globally available. So it should run from 2022 to 2023, 1 year period, and we'll collect this kind of high resolution stereoscopy images, just for information. So thank you.
That's a very good news.
Thank you.
Yes,
Thank you. We
thank-
have now like 2 minutes. Then the break will be starting. So next question is like that. Have there any authenticated, demarcated, calculated floodplain area for around Sirajganj?
Actually, the danger water level in Sirajganj crosses danger level every year, but a few areas of Sirajganj are considered in the embankment for the Brahmaputra right embankment, and so those areas not get flooded every year, maybe because in some year because of embankment failure, but there is few areas that is not considered in the embankment. Those areas get flooded every year.
And has there any forecast for those?
Actually, not appropriately, but the local union Parishad, they collect a floodwater data of floodwater forecast of river, and they just predict that if the water level can rise to 1 meter in 2 days, so it can reach to our village. So they just locally verbally forecast that water can reach in 2 or 3 days, but not a specific or appropriate forecast.
Okay, thanks, Ashik. Sir, may I